Am I audible?
Yes, ma'am.
Okay, then we shall start. Okay, so in the last class we discussed the probability, right? The probability that at least one person has the same birthday as you, right? Where we calculated n value is equal to 253. See, as I discussed in the last class, why I'm discussing the birthday problem. See, it's a example where it's an example to say there is a collision in hash function. If it is not, if you find any collision in hash function, obviously at that point only you should stop using hash function, or else there is a chance for the attacker to attack the data that you are going to send it between the communication parties. Okay, so I completed all this part in last class. So I was discussing this interactive experiment, right, regarding birthday problem. Let's see that simulation again. One second. Huh. So in this example, let's start. So one second, I'm giving already one person is present, Russell, and I'm giving my birthday date here since it's asking 25th October. Okay, so let's consider this is a birthday party wherein initially two persons are present, that is Razzle and myself. Okay, and birthday date is also mentioned. Okay, now according to this example, this person birthday is on November 15th. Okay, so as you can see here, we both of us don't share the birthday date. He has it in November and myself is on October. Okay, so now the question is, how many people do you think we need a room to have a 50% chance that two people have the same birthday, right? So approximately I'll give somewhere say 49. Okay, let's see, will it match with the 50%? So as you can see here, if 49 people are there, then there is a chance of 96.6%, right? So, but we need 50% chance. So let's see what should be the number here. As you can see here, to get a 50%, you need to have 23 people in the room, right? So let's see how it works. Let's invite the last 21 real people like you who visited this party. Okay, so you can see here. Okay, see, when there is a match, I mean when there is two person having same birthday date, then you can find a balloon going there. So it's not visible here. Okay, one second, let me try again. Shade birthday, see where you can see if there is a balloon in the screen, then you can make out two persons sharing the same birthday date. So actually this person is sharing the birthday date with other person. I don't know why it's not visible here. Okay, just assume that here two person is having the same birthday date. Okay, that's why if there is 23 people in the room, then two people can have the same birthday date. Let's see more simulation. This also we saw in the last class. So here we are adding 90 more groups. Okay, so to see the simulation, actually you can see wherever you see the running of this balloon, that means two person having the same birthday there. So for 19 more groups, you can see the success rate here. So the possible is 9 people can have the same birthday date. Okay, so few more simulation is done. I mean, few more trials are tried out, where you can see for 1000 trials, You got here 588 success rate. That means 50% of it. So in a room, if there is a 23%, 2% can have the same birthday date. Let's see according to the maths. See, in this, we are comparing the birthday date with each other. See, here initially, two people, we comparing the birthday date here. One comparison is made, probability is given. When there are four people, when the comparison is made with each other, the probability is given here. When there are 6 people, 10 people, it's 11.7. So when 23 people are there and comparison made with each other, then the probability is 50.7%. How many comparison it's required? 253. This is what we calculated in the previous slide. Okay. So I hope this is clear, right? This is clear to everyone?
Yes, ma'am.
Okay, let's move to the next part. Okay. So this is done. Okay, we'll move to the next part. See here, hashes and how it is compared. As you know here, the arbitrary length of input is given to the hash function, which gives you fixed length hash value or output. Whatever output you get it for the hash function will be of fixed length, and this length is smaller when compared to the input size. Okay. So now the next thing is, if we perform hash function on any input, say its output will be of n bits. Assume that when you perform hash function on any input, the output is represented using n bits. Okay. So then what is the possible hash values for this input? So obviously it is 2 power of n different hash values are possible. Okay. So if the output has n bits, then 2 power of n different hash values are possible. Fine. So now when you apply a square root for this 2 power of n, this can be represented, or this is equals to 2 power of n divided by 2, right? If you apply the square root, it becomes 2n. The square root becomes 1 divided by 2. That is 1 into n is equal to n divided by 2. So this values, when this is the value for this hash function, then we may expect a collision in the hash function. I'll repeat. When you apply hash function on the input, whatever output you get it for this hash function, consider it is of n bits. Okay. Then the possible different hash values for this is 2 power of n. When you apply square root for this, or you can say 2 power of n divided by 2, when you make these many comparisons, then you may expect a collision in the hash function. So if you find any collision in hash function, obviously that hash function, we are not supposed to use it for the communication, isn't it? So so many comparison has to be made, right, to find a collision. So that comparison we call it as a exhaustive attack or exhaustive search. Okay. So to avoid this kind of attack, what we have to do, the n bit, that is output of this hash function, n bit should be large enough. So if any attacker tries out 2 power of n by 2, it must take him a very longer time. So it makes, we have to find the output bit should be large enough so that even though attacker performs the exhaustive search, he may not able to try out all the possible comparison. Okay. So this can be done if n bits are long enough. Fine. I hope this is clear to everyone. Yes?
Yes, ma'am.
Okay, we'll move to the next topic. So this is a simple example where I've already considered this example while explaining the hash function in the starting of this module. So these are the names on which I am performing hash function. Okay, these are the hash values generated for the hash function. Okay, so here you can find there is a collision for two different input. It's colliding with the same hash value. So if this is the case, obviously the attacker can attack this method and he may finds out the actual content that you are supposed to send it to a other party, I mean who are involved in the communication. Okay, so let's see the actual example with respect to birthday problem. So whenever what communication happens between two parties, how the collision can be find or how birthday attack we can find in this example. Let's consider Alice wants to send a message. Consider Alice wants to send a message M to the Bob. Okay, what she will do? She will sign it or she performs hash function on the message. Then she'll generate S. What is S here? After performing hash function on the message which Alice is supposed to send it to Bob. So the result of this is S. So Alice will send S and M to Bob. What happens? Now consider there is an intruder or as we discussed in the previous chapter, Trudy as an attacker. Okay, so let's consider that Trudy will create a message. Here we call it as the evil message. Okay, let's represent it as E. That Alice don't want to sign it. Okay, consider the attacker creates a message like what to say. Alice agrees to give all of her money to Trudy. Will she sign that message? Will she agree for that message where she is supposed to give all her money to Trudy? No, right? So such messages is treated as evil here, and we are represented with letter E. Okay. Next, attacker also create innocent messages where it is represented as capital I. Okay, these messages are those which Alice may sign it willingly, like day to day whatever routine work she has, according to that messages are created. If those messages are sent to the Alice, then obviously she will sign it, right? So such kind of messages are created and that we call it as innocent message here. Next, as we discussed in the previous slide, there can be 2 power of n divided by 2 variants are possible, right? So these many different messages can be generated. So similarly, attacker generates 2 power of n divided by 2 variants of innocent messages. That means different messages which are in favor of Alice. That means if you send such messages, obviously she'll sign it. So such messages, 2 power of n divided by 2 variants are created. In the same way, evil messages are also created. How many variants? It's same as the previous one. 2 power of n divided by 2. See, you all understood why I'm considering 2 power of n divided by 2, right? So in the previous slide, see here. So that is the what point where you can find a collision. Okay, that's why those many different hash values are considered here. Different messages are considered here. Okay, so these many variants of innocent messages are created. So when these messages are created, different hash values are also generated. So for these many messages, attacker will apply hash function and he'll be with different hash values for these many variants. In the same way, for the evil message also, he'll create 2 power of n divided by 2 variants on which he will apply hash function and he'll be having different hash values for these many variants. Okay. Now what attacker will do or Trudy will do, he'll try out all the comparisons, okay, where he'll find when he applied a hash function on evil message, that is equal to when he applied hash function on innocent message. Okay, so out of 2 power of n divided by 2, at somewhere where ei is considered, when he applied hash function on evil message, the value generated or the hash value generated is same as the value or a hash value generated when hash function is applied on some innocent messages. Okay, some innocent message. If this is equal, then what it says, there is a collision, isn't it? So now attacker sends this ik where he finds the hash value which is same as the hash value of evil message. He will send this message to Alice and he asks to sign it. What she'll do, thinking that it is the message that I was signing it. So what she'll do, she'll sign it and returns the message and the hash value of it to the attacker. Okay, once attacker has the signature or the hash value of this Alice, obviously he can again attack all the messages that are supposed to be signed by the Alice. Since h of e of j is equal to h of ik, it says that hash value of evil message is equal to hash value of innocent message, right? So when this happens, obviously attacker will be obtaining the Alice signature on the evil message. So this message can be sent to the Bob now, right? So what Alice will not be knowing, she has signed the message. Okay, I mean when she signed a innocent message which was sent by the Trudy, okay, once she hashed it and sent it to the Trudy, then obviously he'll be having her signature. Using this, he can encrypt many messages and can be sent it to the Bob. So that is one disadvantage here. So how can you prevent this attack? As we discussed in the previous slide, we have to choose an hash function for which n, the size of hash function output is so large that attacker cannot compute 2 power of n divided by 2 hashes. So the output of a hash function, whatever you are considering on the message, should be large enough so that attacker may not be able to compute all 2 power of n divided by 2 hashes. Okay, so that is one solution for this collision problem. Is this clear? Yes?
Yes.
Okay, see, a birthday attack problem, very commonly asked question. Okay, they may ask you for 6 marks or 8 marks. So depending on the marks, you have to explain the content. Fine. Okay, next we'll move on to the next topic where non-crypto hash functions are used. Okay, so here till now we said that a hash function is a crypto which is used in the cryptography, right? There are a few more algorithms which we call it as non-crypto hash functions. These functions are also used in many applications in the market, but this is not as secure as the crypto functions which we discussed in the previous slides, that is SHA, series, and message digest. Okay, yeah. So we'll see few of the applications of non-crypto hash function. Then we'll explain how actually this non-cryptographic function works. Okay, so this non-crypto hash function used for the checksums and error correction detection. So you might have studied CRC, right? Cyclic redundancy check in computer networks or DC, isn't it? So CRC, that is one application. And next, to generate hash tables, and also it is used in cache. Okay, also used in Bloom filters, and also used in finding duplicated records in the database. Caches, you know where the cache is used. While implementing this cache, non-crypto hash functions are used, and also in the database to find the duplicate records, and also used in CRC. Now, do you know what is Bloom filters? Any idea? Have you heard of this? Let's see what it is. Okay, see, this is not there in the syllabus. Out of interest, I have taken this. Okay, suppose you want to create an account in any Gmail or anywhere. Okay, any website. If you want to create an account, you will enter a username. You will be asked to enter username and the password, right? Let's consider the first thing, username. When you enter a particular username which is of your interest, sometimes you will get a message saying username is already taken, isn't it? You might have encountered the situation many a times while creating a account. So username is already taken, right? So you will try some other usernames, like adding birthday to your name, right? And also what to say, and also some other number which you are very interested of, so that those numbers you add it with your name, and you will try creating a username for your account. But even trying many a times, it says username is already taken, right? So which is really frustrating. So there is a solution for this that is called as Bloom filter. Okay, so I mean, how it says username is already taken. So using Bloom filter, it checks the records. Actually, this Bloom filter is a probabilistic data structure which is used to test whether an element is a member of a set. Okay, so Bloom filter, it will check whether an element is member of a set. Let's consider an example. Checking the availability of username, whatever you have given to create an account. Let's consider that checking the availability of username is set membership problem. Okay, where the set in the list of all registered username. Okay, so what does it mean? Obviously, it will check all the registered username that is there in the database, right? So it so happens that it may give false positive results. What false positive results means? It might tell the given username is already taken, but actually it's not. Actually, what I'm trying to say is, whatever username that you're trying to enter, sometimes it says already username is taken, right? So after trying many a times, also you get the same message. So in such case, the Bloom filter is used. This is a data structure which helps in checking the availability of username in the database. Okay. Sometimes what happens, if there is no Bloom filter in while checking the database will return false positive results. That means even though the username is not registered in the database, it will give it is already taken. So to avoid such cases, the Bloom filter is used. I hope I'm clear to everyone.
Ma'am,
Yes?
could you repeat again because I didn't
Okay.
understand.
Okay. See, example is that I'm trying to create an account in Gmail. Okay. So what happens whenever I try to create a username, it gives as username is already taken. Try out some other username. If auto auto username is not suggested by the Gmail, you should consider that case. Okay. Whenever you try to create a username, every time it gives you the message that it's already taken. Okay, so what happens, obviously after trying many a times you will frustrate, right? So to avoid such cases, the Bloom filter is used. That means actually whatever the username that you enter in the field, that will be checked with the registered username in the database. Okay, sometimes it so happens that even though if it is not registered, you will get a false positive results. That means false positive results mean even though your username is not registered in the database, you will get a message saying that username is already taken. To avoid such cases, the Bloom filter is used. Is that clear?
Okay, ma'am, understood. Yes.
Bloom filter ಏನು ಮಾಡುತ್ತೆ registered database ಅಲ್ಲಿ check ಮಾಡಿಬಿಟ್ಟು it will say whether the username entered is registered or not. You can try out the other one, or you can take the given username as the username for the account creation. Okay.
Okay, ma'am. Thank you.
Yeah. So these are the few application. Let's see how this non-crypto hash function works. So let's consider the data given here. That is, data is x, and it follows a series from 1 to n, or x0 to xn minus 1. And each x is a byte. Okay. So 1 byte is equal to 8 bits, right? So consider this is a data, and where each element in this is represented with a byte. When you perform a hash function on this, see, I'm telling you again, these hash functions are not as secure as the one which we discussed in the previous slide. Okay, so define h of x. When you perform hash function on this, so on this data, so what is the hash function? I'm going to use it on this data, that is x1 plus x2 plus x3 till xn mod 256. Okay. So obviously when you perform hash function, you will be provided with the compressed result output, right? So then our question is this a secure cryptographic hash? Whatever the hash function I have considered here, is it a secured one? Okay, so let's consider the output of this will be 8-bit output. Output of, when you apply hash function, let's consider the output is 8-bit output. Okay, so according to the birthday problem that we discussed in the previous slide, it says that 2 power of n divided by 2 tries will give you a collision, right? So 2 power of n divided by 2 will give you a collision in the hash function. So if I applied that calculation here, so one second, why it's not writing. As I said, the output of this will be 8-bit, right? Output will be 8-bit. So when I apply 2 power of n divided by 2, how much it will be? N is 8 here. So 8 divided by 2 is 4, right? So that means 2 power of 4. 2 ones are 2 fours are 8. So this comes to how much? 16. Right? So here 16 randomly selected inputs. For 16 randomly selected inputs, you can find a collision in this hash function. I'll repeat, consider this is the data that I'm going to consider and on which I'm performing hash function, and this is the hash function I'm applying on this data. Okay, according to the discussion with respect to birthday problem, 2 power of n divided by 2 tries will give you a collision. If I apply that concept here, as I said, output of this function will be 8-bit output, right? Applying that here, 2 power of n divided by 2. That means n is 8 here. 8 divided by 2 is equal to 2 power of 4, and that comes to 16. So for 16 randomly selected input for this data, I may find a collision. So what does it mean? Obviously, this is also not a secure hash function, isn't it? Let's see a few more examples. Example x as x, and as I said, this will be byte. I'm going to represent it with in the form of byte. That means 8 bits. If x is equal to 10101010 and 00001111, then when I apply hash function, after applying this function completely on this data, I'll be ended with 10111001. Okay, now consider there is another input, okay, where this is the input that I'm considering. Okay, so if this is the case, hash function of this, I mean output of this uh, value and output of this will be same. Consider I'm applying the same hash function on this data. Okay, the output will be this one, 10111001. Now I will consider another input. I'm considering it as y. Okay, apply after applying hash function on this input, I'll be whatever hash value that I get is same as this one. That is h of x is equal to h of y. That means output of this and output of this and output of this is same. That means what? There is a collision, right? So obviously when you find collision, this method is not secure. So you can't use this hash function. Let's consider another example where I'm considering the data as x. Here x series is considered, where I'm using hash function as this one. H of x is equal to n into x1 plus n minus 1 into x2 and so on till xn mod 256. If this is the hash function I'm using, let's check is it secured one. Okay, so note that here I've considered the input as 10101010001111. On this data, I'm applying hash. Okay, so now I'm swapping it. I mean, so one second, I missed a point here. Here, see, I missed this point. Here, x is x. The value is this one, right? This is a pair, right? So when you swap it, so let's consider this is A and this is B. After applying hash, this is the value. When you swap it, you can see the y I'm considering here is I'm writing this B in the place of A and A in the place of B. Okay, I'm just swapping these two. Then I found a collision here. Okay, so I forgot to tell you this. So on the next case, I'm using different hash function. Since the previous one is not secure, I'm just swapping it. So here, see, I'm 1010101000001111. I'm just swapping it. See, if I swap these two A and B value after performing hash function, this hash function on this, it is not same. Okay, but there is a chance that hash of some other input, say this is not, I'm considering this 00000001 00001111. I'm considering this as one input and 0000000000010001 this as another input. After applying hash function on this and this is same. See, I'm not swapping here. What I'm doing, I'm considering two different inputs, completely two different inputs, on which I'm applying this hash function, this hash function. See, this is one input, this is another input. When I apply this hash function on these two, the hash value is same. So what you can see, which hash value I'm considering? This one. After applying this hash function on this input, the output is same. So in this case, you can see it is there is a collision for this hash function also, right? So since it is not secure here, but this is used in a particular application called rsync. What is rsync? Have you heard of this word anywhere? Rsync? Rsync is remote synchronization, and this is used as a command, okay, for copying and synchronizing files and directories remotely as well as locally in Linux or Unix system. So this is a command which is used to copy and synchronize the files and directories over the network or locally in Linux or Unix system. Okay, so this helps you to copy, as I said, not only files, the data, I mean, whatever data present in the files, copy and synchronize remotely and locally across directories or across disks and networks. Okay, and also in some other cases also, you will study mirroring data backups in SAN. Okay, then you may understand this rsync command. Okay, as of now, you just remember this what non-cryptographic hash is used in rsync application. Fine. So another, as I said in the first slide when I started this topic, it is also used in cyclic redundancy check, right? So here it is a long division calculation where the remainder, divisor, and dividend and all considered, right? So after performing CRC check, the remainder, sorry, for I mean the CRC which you consider, the choice of divisor, with the help of choice of divisor you can find the collision easily. Okay, that is one thing I just want to mention here. So CRC actually, in many I mean many people will treat CRC as a cryptographic function, but actually this is a non-cryptographic function which is used to check the what error codes, error detection code, as a error detection code. Okay, so this also helps in finding a collision in the data. So what is the time now? Ah, okay. Yeah, that's all for I mean, that's all in this class. Let's continue the rest in the next class. And one more thing, one second. So any doubts still here? Any doubts? Answer me. Any doubts? Any doubts? No? Okay, okay. See, I have class, I mean, just wait, I'll take the attendance. Stay online. Diksha ma'am. So stay online. I'll just try to take the attendance. Okay, drop your name and USN in the chat box. Okay, and don't leave the class. Just stay for a while. Drop your USN and name in the chat box. Don't leave the class. Let's everyone complete it. Yes, that's it. Okay, listen. I want you to take up the last module, that is fifth module in your syllabus as subject seminar. It's very interesting. where in this module they have discussed the applications of cryptography. Okay, so I want you guys to take up this and present it whenever it's possible. It's not the difficult one, only applications are given. So form a group or a batch and give me your names as soon as possible. I'll create a Google form and share it. You create it and create a group and send it to me. Okay. Any doubts? Yes.
Ma'am,
Tell me.
I,
One
I
second. One second. One second.